Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, an update on 5G in the Department of Defense with returning guest Leland Brown. Leland, welcome to the show.
Hey, Darren, how you doing? As I always say, you're one of my favorite people to talk to, Intel and not Intel.
I completely snowed you over, Leland. I completely snowed you over.
Yes, you did.
Yeah. So, hey, Leland, this is your fourth time on the show. Yeah, I love talking to you. It's so much fun.
Hey, man, listen, let's keep it going. You know, it's always informative, and it's always good to talk to friends, especially you and others at Intel. And as you can see, I am wearing my Intel shirt. So
yeah, but you're not with Intel anymore. You jumped ship. You're over at Capgemini.
Yeah,
big important position over there. You're a director of federal and a distinguished engineer or principal engineer. How do they work at
principal? Yeah, principal engineer and federal director for anything around advanced comms for our defense and aerospace. So really the goal is to develop our capabilities and present Capgemini as a capable partner within the defense marketplace. And we have some strategic partnerships, including one with Intel. So I figured for this, let me take out the old dusty Intel shirt to put it back on, and
I love it.
Maybe I'll go mow the lawn in it later on. Or...
That's hilarious.
So, no, but no, it's always good to work with Intel and the team there. It's always great to really interface and be a part of the team. So thank you.
Thanks for coming on the show today, Leland. And today we're gonna kind of lay the groundwork for 5G. I mean, there was all this hype around 5G, completely going to change everything. We've talked in depth about it on the podcast before, but let's get a current state. Where are we today with 5G in Department of Defense? Because I got 5G at home. I got a 5G little thing at home. That's not the same thing as what we're talking about here. This is very different.
Got a couple of 5G phones here, the whole nine. So
yeah, exactly. So
very different. Yeah,
it's very, very different. So let's dive in. Do you want to talk about the use cases first, and then the state of the adoption? How do you want to approach this?
Well, you know what? I'm gonna hit timelines. You know, and as you stated, this is my fourth time on, and so in our past discussions, we talked about the historical context of this. I think it would be great as a baseline today. So, I go back working with the Department of Defense back in the early 2000s. And, as I mentioned, my first job was out of the Communications and Electronics Command out of Fort Monmouth, New Jersey, before they closed the base down. And back then, it was really the goal of that group, which I was under the Space and Terrestrial Communications Directorate, was to really take commercial technologies and I would say position them to be adopted by the Department of Defense. So what does that mean? Doing a lot of field trial testing, working with a lot of the different system integrators at the time to deploy systems. And there were a couple of programs back then that were geared towards that whole commercial technology adoption strategy. One was called Joint Tactical Radio Service. That's a four-letter word to some people within the defense marketplace nowadays. You may hear it's called Jitters. There were other programs called Net Warrior, FBCB2 for Brigade Command and Control. A lot of different programs that they were driving back then to adopt what was then the 2G, 3G platforms, what was then known as wireless LAN, even Bluetooth at the time. The goal, try to develop a common radio stack or architecture that can be used across the joint forces. So Army, Navy, Air Force, even some level of multi-dimensional or say multi-domain. But the overall goal was how can you get a common radio architecture that can be utilized by all the joint forces using a common waveform portfolio. I think it was 32 waveforms at the time. And, a lot of upside, a lot of promise. Downside was everything was really proprietary architectures. A lot of that controlled by the system developers at the time. So it was just hard for the Department of Defense to get a true common stack when you have all these proprietary architectures being presented as a solution. So what happened was you got a whole lot of split architectures out there, right? L3 Harris had their own HRS compliant radios. Um, I won't say Lockheed Martin because it really wasn't a radio house, but let's say General Dynamics, a couple of other system integrators that have probably been absorbed over the past few years, ITT Industries and the like. In a way, the program, I won't say crash and burn, but I said that four-letter word because there's a lot of frustration out there. When you mention JTRS, I usually see a person's face kind of cringe a little bit. Say, "Oh man, what happened with that?" But billions of
So,
dollars.
yeah, so you
Well
attribute
spent.
that to you attribute that to the vendors not playing nice with each other, basically, not following a common standard. I mean, we see this in
Well,
Department of Defense all the time with
yeah,
the big systems integrators. Hey, I want something proprietary because it locks me in. That's a problem.
right. It is. It's something that's caused a lot of frustration over the years. And I'm being very open and honest here because hopefully this podcast is seen by tons of people. At the same time, some of those viewers are going to be system integrators, I'm hoping. And the reality is, when you look back here at this picture on my wall back here, that represents Net Warrior. I made that 2002. And when I always look at it, the key thing that comes to mind is one, when I was working on this program, there were soldiers that we had presented these platforms to, and they all told us, "Hey, we need this to work, and if it's not going to work across the joint forces, what is the point of it?" So you're right. A lot of internal SI or system integrator focused efforts on their own platforms to ensure that they have a level of, let's say, dominance in
Competitive
the area.
advantage,
Yeah,
right?
right,
Yeah,
right.
competitive advantage.
Yeah.
So have things changed with 5G?
So just to kind of go down this historical track a little bit, what came out of that was 2016, a new technology architecture came into play, 5G. At least the hope of it, right? We were still pre-commercial, but the Department of Defense saw that and said, "Hey, this may be our opportunity to finally have a commercial stack that can be deployed across the battle space that is now a software-defined virtualized architecture." And that's the key thing. There were some key aspects around 5G that was very attractive. And I'm saying was not that we're past it, but at that point in time, one is based on a very powerful general purpose hardware, i.e., Intel. It's from that point in time, a lot of the CPUs are far more powerful than what you saw within the early 2000s. So that's one. Two, there was a virtualization of the hardware layer to become a software defined layer. So now you can deploy. You remember I mentioned these portfolio of waveforms. Now you can software define that layer and now have multiple waveforms on one architecture, software defined as compared to hardware defined. So it really opens up the capability, right? The functional blocks of 5G can be disaggregated or let's say distributed across different compute servers, where that just wasn't the case back then. So now you can spread the functionality of the system across the battle space and even have systems that can kind of shift over, to another function. Let's say the baseband can now shift over to the RU or what have you. Um, and then, the utilization of unlicensed bands. And then on top of that, the overall open architecture. So that became a very attractive element. So in 2019, to kind of fast track this, they started a program called the 5G Requests for Prototype Proposals and backed that up with not only consortiums that were driving out these different proposals, but they had funding tracks, $600 million worth of funding went to the first Trench 1 RPPs in 2020. There was an OTA called Spectrum Forward that was funding, I believe, parts of Trench 1 and even Trench 2 RPPs. And I think The experimentation sites, there's north of 15 different experimentation sites across the country. And when Joe Evans was leading that effort out of OSD, the goal back then was to say, hey, let's take, quote, 5G and do a lot of experimentation so that the Department of Defense can get the capabilities out of the technology that maybe the commercial side wouldn't, develop because there's no real path to revenue. And that's where we stood from, let's say, 2019 to early 20, late 2022, early 2023. That was the foundational aspect of the adoption of the technology.
Okay, so let's take a look. What makes 5G different? I just want to reiterate what I think I heard you say.
Right,
The virtualization gave me flexibility, so I could deploy several different um, technologies with the same hardware layer, which
right,
means flexibility, reliability. I could distribute it. There's a lot of benefits to that. Money was there to help support the research funding.
right,
And there was a consortium of vendors that came together and said, we need a standard.
right.
Is that right?
Yeah, pretty much. And you hear a lot of times in terms of 5G, hey, the greatness of it is it can give you faster data rates and throughput, and you can watch Netflix and download videos. No doubt that exists. When you say 5G, and I'm going to hit this point next, is the term 5G kind of puts that thought process in your head, right? Like you think of a cell phone, you think of the use case of a cell phone, you say
Right.
5G,
Yeah. Yeah.
right? So for the DoD, that doesn't necessarily align up to the goals here, right?
Hey, let,
So,
let me call and talk to my
right,
general on what I should do. Right. That doesn't make sense.
exactly right. So I was always, and Darren, you and I have talked about this. I was always a little adverse to the 5G monitor being placed on the efforts of the DoD around this. Everything that I talked about didn't mention 5G. It mentioned the architecture
Right.
behind.
Yeah. Yeah.
Right, right. So that's always been the true adoption strategy, is to adopt the architecture, because now it gives you, as you stated, a far more flexible system that can be flexed to these different use cases, that can be spread across the joint forces, and even can go multi-domain, terrestrial,
Well,
satcom,
and it can
and
handle multiple vendors, right?
multiple vendors.
That's
Right.
that's the
So,
other key thing is I can have interaction between the different vendors, integration between the different solutions, which is critical.
oh yeah, yeah, and the underlying technology was a significant architectural shift away. As I mentioned, there were a lot of proprietary platforms. Ericsson and Nokia, some of the major RAN developers have really proprietary boxes, at least for 4G on back. And when 5G came along, it really opened up and, I will say, unlocked the vendor lock that the Department of Defense was really concerned with. And as you mentioned, back when they were trying to do this under JTRS, was a lot of lockdown of the vendors, and it really didn't allow new players to come in. So this is a commercial adoption strategy, along with the Department of Defense wanting to have access to the technologies to enable their use cases, right? And a lot of use cases, you can talk about tactical radios, you can talk about unmanned systems, data points at the edge, synthetic training environments, of course, base networks, but really, I would say on-premise systems. And the private network aspect of 5G was really important, because now you can have an on-premise network that's totally decoupled away from a carrier. Highly attractive, right? You don't want to have, the having a dependency on a carrier when you wanted to deploy a private network on a
Especially in
battleship.
wartime, right? I mean,
Exactly. Right.
right?
Exactly
You,
right.
you
So,
want you want that flexibility. You don't want dependencies. I
exactly.
totally get it. This is fascinating because it sounds like the military has fallen behind in some technology. So now they're going to common commercial um, common commercial offerings as their base now. Uh,
Well,
is that completely true for 5G?
so let's provide some clarity with this here. It's it's known, or at least accepted, that the largest investor into the adoption or the proliferation of 5G technologies has been the Department of Defense. It's spending billions of dollars on this, right? Augmented with the fact that there's two driving factors, which kind of shifts over to the next point. What has changed, right? Um, when you looked at from 2019 to 2022, the goal was to experimentations. Then something happened. Another gentleman came in and took over the overall strategy under the office of the Secretary of Defense. His name is Tom Rondo. He comes from DARPA, and I've known Tom for a while. And then speaking to him, when I knew that he was coming over, I said to myself, things are going to change here, because the goal is to get systems that are deployable out there, not necessarily experimentations, to
Yeah,
determine.
move out of experiments in the lab into
Exactly.
something, yeah, I can actually
Exactly
use, right?
right. So really his goal coming in was to say, okay, we're going to shift the focus here. We're going to go from quote 5G experimentation. And this is the first time I actually heard someone within the DoD use the term ORAN specifically, meaning keying in on what the architecture focus points are, and then
Yeah.
stating that explicitly, to the commercial and any defense and marketplace, and then stating we're going to have something in place right now to get these into deployable solutions. So we're going to start to move our focus away from experimentation to figure out what can we get out here soon and fast. And there's a lot of forcing functions, beyond that. There's a need to have a benefit for the nation as a whole to be a lead point. And if it isn't 5G, what's coming afterwards, right? Right now we can say that the U.S. isn't necessarily leading in 5G technologies. At the same time, there's a lot of geopolitical forces out here that require us to have deployable solutions very soon. I'm not going to get into those discussion points, but I think we
Yeah,
all know
yeah.
what's happening, right? So there's a forcing function. Those forcing functions, along with the fact that, as you mentioned, they don't necessarily want to be in this vendor lock with these big players, keeping out the innovation of some of the smaller players. Which you see a lot of innovation coming in some of these smaller companies. So he's come in and basically stated, hey, um, in many ways, if you show me another PowerPoint slide, that won't be enough. I need a deployable solution. So a lot of the effort now is one focusing in on what parts of the spec need to be uplifted, or let's say driving a lot of investment strategy in to ensure that the Department of Defense is getting that, augmented with the fact that if the commercial space uses it or not, at least it's been developed, right? So what drives that? Of course, is funding, right? Use case requirements. How can you start to scale this in between both the commercial and federal sectors to make it not necessarily a path to revenue, but at least a value add for the for the nation as a whole. So that's been the shift away from
So that
experimentation.
that's an interesting position for me to hear. The Department of Defense is actually funding commercial 5G. It
Yeah.
makes sense, right? Because look, how I have 300 million people in the United States. How many are using 5G every day? 200 million have their own phones. That's
Well,
200 million testers, right? So that's two. You're proving out the technology in a really great way that can then be leveraged by the DoD for their comms. I think it's actually a brilliant move, and we're not locked into this proprietariness that we've had in the past. Which, as I'm glad you explained it, these big companies, they're so bureaucratic they can't innovate anymore. So the new architecture, the ORAN architecture, or the you know opens it up. So now I can have new, innovative startups that are doing new and interesting things instead of being so risk averse they can't make any decision. They can't innovate anymore. So
right,
I think it's a
and
great business model. It's fascinating.
I mean, exactly. So when you look at things like microelectronics commons, right? That's an
Yeah, yeah,
effort,
yeah, yeah. The ME
right?
Commons project. Yeah,
Exactly. Enemy Commons, a part of that track is multiple technology development tracks, but there's a track for 5G, 6G, and that really provides a level of innovation between smaller and larger players, right? You have companies like Intel, large player in this space, and working with smaller companies, developing hubs and cores that key in on these different technology points. And it really fosters this innovation track. And this kind of keys into under the Office of the Secretary of Defense. There's a program called RADAR, Research Defense Innovation Reserve, or something like that. I may have gotten that wrong. But the goal of that is to foster innovation. So a lot of the goals that Dr. Rondeau is driving feeds into the Raider objective. And that objective is to have these cross functional teams. And now as these experimentations go into deployable programs, they're going to transition a lot of these experimentation sites over to the DoD CIO office to now drive it towards a deployable solution. And we're going to start to see the first phase of that come out in late October, I believe.
You said October we're going to start seeing, these more things with Raider. What about practical? When am I going to start seeing 5G deployments in DoD, or am I already starting to see them like battlefield ready, not experiments or one-offs? When am I
Right.
going to see like some real meat on this bone?
Great point. So there's two tracks that are going to come. Well, three tracks. One, what I mentioned, transition of some of these experimentation sites to
Right.
the DoD CIO office to turn them into programs of record. Third track, you're going to see out of Tom Rondeau's office an acceleration track in terms of hardening some of these solutions along three technical lines. Unlimited software-defined radio platforms, meaning getting, I won't say experimentations, but getting a focus on deploying systems that have unlimited SDR. Hyperdimensional software-defined networking, meaning when you look at the dimensions of the data, AI, connectivity, having that's forming what you call a data fabric across the battle space, driving some, I would say, research and development within those areas, along with mobile IP protocols, right? That's the second track. You're going to start seeing some RFPs come out down that area. And then the third track is there are companies that are there, or at least groups of companies that are saying, hey, we can provide you a deployable solution now. Example, Capgemini is working with Intel along with some other OEMs and software developers to actually build a deployable solution now, right? And present that. And we're not the only group that's talking this way at this point because we realize the call. The call now is let's get out of this experimentation focus point and give
Yeah,
me
yeah.
some
We need to actually produce something now. Let's get
right.
it done.
And this company's literally right there. I mean, I'm a firm believer that if we really put some efforts together, you can see something that's deployable very soon. Very soon. If not just taking, the Lego pieces and popping them
And
together.
popping them together. So you
Right.
think the technology is mature enough where I can actually put this in the battlefield? Not a problem.
I do. I do. I'd say the only thing right now that's the struggle, right? And it's the hardest, to me, in my opinion, the hardest part of the engineering effort is there's an interoperability issue between two of the functional blocks. So, when you talk 5G, I tend to say there's five functional blocks. You have the core where a lot of your services would sit, right? And then you have parts of the RAN, the central unit or CCU, the distributed unit or DU, and then the radio unit or RU. CU, DU, RU to me make up the RAN. And then the fifth part is the edge computer, the MEC, right? And we could talk about edge orchestrations and everything else. But to me,
Yeah, we can
those are
talk
the
all
five
day
things.
about that. Yeah.
Exactly. So the interoperability between the RU unit and the DU is where you see a lot of issues right now. There's very little US based radio developers right now because it takes a lot of engineering effort to do an interoperability between the DU and RU. So when you say open RAN or ORAN, really you're talking about the interop between those two
between
functions.
those three things in the middle, right?
Well,
The
really,
CCU, the RU, and the DU, right?
well, so the CUDU is considered the baseband function, and a lot of that
Okay,
has been virtualized. Like for instance, Intel's FlexRAM, it's a virtualization that companies come in, they build what they call layer two, layer three CUD functions on top of that. But I'm really referring to the between the distributed unit, which drives the RU. There's very few interoperable RUs across multiple DUs right now, and that's an effort that's going to have to start to ramp up. There's a lot of innovation requirements in those areas.
so if I'm a graduate, if I'm a graduating this year from my bachelor's degree in electrical engineering or signal processing, that's where I want to go. You're
I,
saying
I
there's a
would
shortage.
I would say yes. I mean, there's a lot of need there. I have a tendency to want to fill the gaps, Darren. That's a gap right
That's
now.
it. Yeah, yeah.
Uh, yeah,
That's a gap.
yeah.
So
I mean,
all you students that listen to the podcast, all 10,000 of you, there you go. There's a
yeah.
job. If you want a
Hey,
secure job for a long time, you got it right there.
hey, get into software defined radios. Man, to me, STEM is always something like, of course, I mentor young students in this area, especially high school students. And I tell them, I say, hey, we need gap fulfillers. We need people who can really innovate. So you are spot on. So thank you for bringing that
Well,
up. But yeah, those are the next stages of the challenges. So, and the focus point that I see coming up is the deployment, and well, in 2024, um, my my hope is that we will start to see deployable solutions, and we're going to start to drive this into things that can be actually positioned to the soldier to take on. And I think we're very close to that. And I think we have a good lead point within the OSD that's going to drive that effort. I think it went down the appropriate steps. When Joe Evans was leading it, trying to understand what are we adopting here. So those experimentation sites, they did add value. They did, but
of course,
as
yeah,
a
yeah.
yeah, but as I mentioned with JTRS, it's always in the back of the mind. Are we going to go down the same track?
Yeah,
Right?
yeah, of
How can
course.
we avoid that? Right. So that's always been kind of in the back. So how can we? And now to have that shift point to say, hey, no, we're going to turn this into something that can be deployed. That's the goal now. So I really am hoping to see some deployable solutions and some of the things that we are
Well,
working
yeah, I
with
mean,
Intel.
this has been kind of your baby for 18 years.
Yeah.
Yeah,
You know,
that's a long time.
yeah, Darren, I thought about it when I first started this back in CCOM. My oldest child was 5. He'll be 28 this year.
My goodness. That
So,
makes you old, man.
oh man, yeah.
Man, that
So
makes you old.
yeah, so he told me about 2 months ago. He said, "Dad, you've been talking about this all my life." I said, "Yeah, I have." Yeah, so his entire lifetime, but it's an exciting time. I really think we're there, and it's a
Yeah, to
state of growth.
finally to get so close. It sounds like
Yeah,
it's ready to go. Let's make this thing happen.
yeah. Let's make it happen. I said the partnership between Intel and the Capgemini is something I'm really pushing. I felt being a far more effective partner on this side of the track for the Intel team. I think it's important, and we can really start to drive some solutions together here, along with some of the other ecosystem partnerships out there. So,
Well, it is an exciting time when you put that much effort into changing the world, which is what you're doing. You're changing the industry. You're moving things forward. Leland, as always, it's a pleasure to talk to you. And I learn so much every time I talk to you. It's so much fun.
well, Darren, like I said, you are one of my favorite people, and really, yeah, let's keep this going. More than happy to bring in some of the other Intel players, Anna, Rob Watts, Stan Mo. I'll do some name drops of some of the famous people on the team. So yeah, anytime, Darren. Thank you so much for this.
Sounds sounds good. Thanks, Leland.
All right, thank you. Okay.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.